All right, let's begin. We have a lot to talk about today. It's the last Python lecture, and we are going to launch right into it and talk about classes. What's going on there, though? Thought I cleared all the outputs. Let's try that again. Okay. So we have seen a bunch of data types in Python, like the dictionary, like the NumPy array. The dictionary was built into Python. The NumPy was some third-party library that's not part of the core Python, but we imported it. Today we're going to talk about creating our own types. And so these things are called classes. We will just say types and classes are pretty much the same thing for our purposes. And then an instance of one of those is an object. So if I go here, D is a dictionary. D itself, the type of D is dictionary, and dictionary is a type. So we could say D is an object of type dict. Okay. Or an instance of type dict. So there's an isInstance function in Python which just says, is D an instance of type dict? And it says yes, in fact it is. So why do we want to create our own types? I'm going to use an example, just a kind of toy example of a circle in 2D space, just a circle. So we have a circle, and we want to do some stuff with it. So we might want to change it. We might want to calculate some things. So let's say here's our circle. It's located at the point 2, 3, and its radius is 1. So you could just imagine that circle in the coordinate plane. And now there's some stuff I might be interested in, like the area of the circle, the circumference of the circle, and the distance between the circle and the origin. Hopefully I didn't mess these formulas up, but if I did, it doesn't really matter, because that's not what this is about today. So I have some functions, and I can call these functions on the data. So distance xyr gives me some value. The area gives me some value, and so on. So I'm using the 3 Python variables x, y, and r to represent my circle. Those are the 3 kind of properties I need to define a circle, and then I'm calling some functions on it. OK, that's all good. And now maybe I want 2 circles. So here's another one. And I'm going to have to use some different variable names. I picked x2, y2, and r2. And now I have a different circle that's centered at -3, 4. And it has a radius of 0.5. And I can call dist on it. And you can see this is getting kind of annoying because I'm only going to have x3, y3, r3, and so on and so forth. And also it's kind of error prone because what if I accidentally do this? What if I call the dist function on the center from one circle and the radius from the other? It's annoying that the data for a circle, which is a single object in our minds, are spread across 3 Python variables, which is more hassle and more error prone. So approach number 1 to this is just wrap everything in a dictionary. Here we go. And that solves some number of the problems, because now circle 1 is a single Python variable, and circle 2 is a single Python variable. And OK, now I'm just being fancy with my Python syntax, but the star just it allows you to take dictionaries and kind of unpack them into the arguments of a function. That's not really the point I'm trying to make. I can just call distance on circle 1, and it gets the job done. And now I can't make that mistake anymore of mixing and matching between the radius of one and the center of the other, because I've taken all the data for a conceptual circle and put it in a single Python variable. So that's pretty nice. But it's still not perfect. So here's one problem with it. Here's my circle 3. My circle 3, I accidentally named x, z, and r instead of x, y, and r. And now if I try to do the same thing, I get an error because there's supposed to be a y and I was giving it a z. So again, I'm still not imposing all the structure that we have in our minds into the code. When I do this dictionary approach, I'm still being a little loose, and I could mess it up. Okay, so classes are going to allow us to take the structure in our brains and put them in Python code. And we'll talk about that very shortly. But any questions about this motivation for classes? Okay. Yes. So another thing, we'll see. It's also going to be more convenient in terms of functions. We'll get to that. Okay, so here's the syntax for a class. The word class, and then the name of the class. So typically starts with a capital letter. And I just have a little doc string. You should just put a little doc string explaining what your class is when you make one. It doesn't have to follow the particular structure that we talked about for function doc strings, but at least put something describing what it does. So now we indent inside of the class. So all this stuff is inside of the class, and this function init, we call it a method now instead of a function when it's inside of a class. Pretty much every class is going to have this init method. And it is the method that gets called when you make a new class, make a new instance of the class. So all it says here is to make a new circle, you have to input x, y, and r. And then we're just going to store x, y, and r in ourselves. And I'll talk about the self thing a little more in a minute. So here's how it works. I run this code, and now I can make a circle. And so you can see I've made this Python variable circle1, and I looked up its type, and it's not dict, it's not int. It is a type that we made up ourselves. We are defining this new type called circle. And one thing I can do is I can access the stuff inside of it, not with square brackets like in dictionaries and lists, but with the dot. So circle1.x grabs me the x field of the circle object. And when I made it up here, I said x was going to be 2, y was going to be 3, radius was going to be 1. And so now I can access that data. And so far, this is not interesting. So far, this is basically the same thing as a dictionary. I can put 3 things in it, and I can get those 3 things out. It's slightly better than the dictionary because I can't get the names wrong with x and z because they're now always called x, y, and r no matter what. But when it gets more interesting is when we put in these methods. So here are these methods from before. So again, these are indented inside of the class. So these are methods for the class, and let's talk about them. So first of all, there's this argument self. You don't typically when we define a function, we do def, a, b, c, and then when we call the function, we expect to pass in 3 things. But self is not actually going to be passed in. So we'll see that in a second. But you're always going to have self be the first argument in a method. And what self does is it gives you, as crazy as it sounds, access to yourself when you're inside of the method. So here, if I want to get the radius of the circle in question, I call self.r because I'm saying get my own r. So the area of myself is pi times the radius of myself squared. That kind of makes sense. And likewise for these other things. So one thing that's nice here is I'm not passing in the arguments x, y, r every single time, so it's not like I need doc strings explaining for all my million methods what is x, what is y, what is r. It's always the same thing every time, so I can just have those in the class, describe what they are once, and then use them all over the place. And so again, it's that structure in our brain that we're kind of now leveraging with this new type of code. Okay, so here's how we call such a function. We make a circle, and then again we use the dot, but this time we're not retrieving data out of the class like we did with circle1.x, but we are calling a method, dot area. And now, again, I don't need to put anything here. I don't put self in here. I don't put circle 1 in here. What happens basically is that the thing before the dot, which is circle 1, that becomes the self when we're inside the method. So when I'm inside that area method and I'm referring to self.r, it is the radius of the calling object. Questions or comments about this?
In the class, what?
Victor, right?
Yes, Victor. Yeah, sorry. In the class, what does it mean? Like the init is the initial values? Or?
Yeah. So what does init mean? So this thing here, this line of code, it's creating a new circle. So this is the name of the type. Remember, right? So remember when I wanted to create a new dictionary, I could do d equals dict, right? So in general, when we want to create a new thing of a type, we typically do the name of the type and then parentheses. So what was actually happening when we did d equals dict is it was calling the init method of the dict class that someone had written. And so basically, you don't actually, you couldn't do circle.init because circle 1 doesn't exist yet. So the very first time you make it, you can't really use this syntax down here because you're just making it. So the syntax we do in Python is the name of the type is the syntax you use to make a new one of something. So dict makes you a new dictionary, circle makes you a new circle, numpy.array makes you a new array. And when Python sees this, circle 1 equals, and then the name of some type or the name of some class, it says, oh, that means you're trying to call the init method because that's what happens when you make a new one of something. And then it's literally just calling that function. So these 3 arguments, 2, 3, 1, get put in here, x, y, and z. And this particular init method doesn't really do anything interesting. It just says, hey, I want to use those things later, so I'm going to store them in myself. And then I'm not going to actually do anything further. But you could have much fancier init methods that do a bunch of stuff. Does that answer it?
Okay.
You were first. I forgot your name, though.
Me?
Yes.
Anas.
Anas.
Yeah.
Okay.
So would you recommend having doctrines for the functions inside classes?
Would I recommend having doc strings? Yeah. So just like you have doc strings in functions, you should have doc strings in these methods. It's just I didn't bother with like area because I thought it was pretty self-explanatory. But yes, you should have doc strings. Aran?
Correct, yeah. So this is equivalent to main or constructor. Is it equivalent of a main?
Is it what?
Is it this init method?
Yes.
Is it equivalent to the main method or is it equivalent to the constructor of the program? So
It has nothing to do with main.
like in Java and C# we have main class, right? So when we call,
Oh yeah, it's the constructor.
it's a constructor.
Yes.
Okay.
Yes. So for those of you who have heard the word constructor before from some other language, this init is the constructor. Yeah. There was another question maybe? Over here? No? Yes. So I'll just say Okay, so I can call other things. Oh, I have that down there. I don't need this. Right, so we've seen this before, making a new dictionary. Just a minute, Tom. And we've in fact seen this dot syntax before as well. For example, when we looped over a dictionary with d.items, that was calling a method. It was the name of the dictionary object, dot, and then the name of the method. So we use that syntax without really calling it that, and now we're starting to create our own. Tom?
When we define a class, we need to define all its variables like at the time where there are scenarios where maybe you have to like include like a z eventually.
Yeah, Tom's question is we have to define all the variables right away. So the language is not forcing you to do this, but I typically would, in the constructor, get all my variables sorted out rather than creating new ones later, and I might just initialize one to none here if I'm not ready, and then I might fill it in later. But I think that's a good idea because I kind of want to look in here and see what the data is going to be. And in other languages, you have to specify it earlier, but in Python, Python allows you to get away with a lot, but I wouldn't recommend taking advantage of that. Nikki?
Yeah.
Nikki.
For the variables, can we pass just x or y or r, or do we have to pass the sum?
Can we pass just the x or the y or the r? So no, this init, just like we have other functions with 3 arguments earlier in the course, this is a function with 3 arguments. None of them are optional arguments. You could have optional arguments, but here none of them are, so you need to pass them all in. But yeah, you could certainly say the default radius is 1, and that would be valid. Maybe that's a good idea. Why not? Okay. Let's keep going then. Okay, so here's, oh, I'm just making a NumPy array. I see. Make a NumPy array. So yes, this dot thing, so a dot shape, a dot size, we talked about that last time. I'm again just showing you, you've used this dot syntax a bunch of times. You can think of these as properties of the array. Those are not methods, there's no parentheses, just like we did circle.x, circle.y, circle.r. Here you're kind of close enough looking at properties or fields of this array. And then we also had functions like this. In this case, the a.sort function actually changed a because it turned it into a sorted version of itself. So, yeah. Okay, so here's a new task. Find the distance between circles. So here's this wonderful thing. Dist between, this is in the old way of doing things. x1, y1, r1, x2, y2, r2. Explaining all this stuff, it's a giant mess, and then implementing it, and I guess it does work, but look how much nicer it is in the class universe. We just have a new function, dist between. It takes in itself and another circle. So other is of type circle. If I had a proper doc string here saying the type of other would be circle. And then I just do self.x, other.x, self.y, other.y. And then I can just call this between, I didn't actually do that, I should. I don't know. Right, so circle 2 dot dist between. Now self is going to take on circle 2. The only argument was other. I pass in another circle, and then just such nicer code than the thing with 6 variables in it. It's quite nice, tiny.
Let's say you created another class for squares. Could other be a square?
Absolutely, yes. The question was, if we made another class for square, could other be square? Absolutely. Other could be any type of Python variable of any type, and you can do whatever you want with it, including finding the distance.
Including call its methods from the other class?
Yes, absolutely. So inside of here, whatever the type of other is, you can just execute any valid Python code. So if other was a square and it had its own like perimeter, you could totally do that. You can just call any code once you have other in your grasp. Yes, what's your name?
Braden.
Braden.
Where would you describe your arguments?
Where would you, yeah, so, I mean, you can just do the same old thing. Other is a circle, the other circle, all that kind of stuff. So
It would be in the function and not in the class.
right, well, this doc string pertains to this method. So each method should have its own doc string. But then here, this is just a little bit talking about the class.
So if each method had the same arguments, could you just put the description of.
The question is, but the whole point of this is so you don't have to have each method have the same arguments, right? That's what we were doing before in the old way, which wasn't very pretty. But now, self is always going to be in there. You don't have to describe self. People know what self is. And self gets you access to all those things, so you don't need all those methods to take in x, y, and z. Furkan.
So how about if for other we have a square instead of a circle, then how can, let's say, we just make a condition that it works for circle but not for other shapes?
Well, okay, the question was, how do you know if other is a square or a circle or whatever? So just like we were checking before, is this thing an integer? I mean, you could always say, if you wanted to, if not is instance other circle raise exception. Like you can check it just the way you would check anything if you wanted to. Yeah, what's your name?
Gaurav.
Gaurav.
This will raise error, right? Because it is doing other.r. If that square will not be having a
True, yes, so that's fair. This would have probably errored out anyways. If other did not have a field called x, you would have gotten an error. But this is one of those cases where it would probably be more graceful to raise an exception with a meaningful message, like other must be a circle, rather than just let it throw whatever error would have gotten thrown downstream. Okay. Oops. Ah. Oh. Why did that happen? I think I know why that happened. Ugh. Okay, let's not worry about that right now. Forget it. Okay. So, changing data in a class. So we can call the circumference of the circle. We can also, so just like circle.r would retrieve the radius of the circle, we can also set the radius directly like this. Isn't always the prettiest way of doing things, but here you can see I set the radius to be 10 times bigger, and then I got the circumference being 10 times bigger. So you can just directly modify the data inside the class, but it is typically better and more elegant to actually create methods that do that. So for example, this method, translate, takes in two arguments, delta x, delta y, and it just moves the center of the circle by delta x, delta y. And that's nice because, again, if someone tried to, because once you're in a method, you can check things. So if someone tried to set the center of the circle to something that didn't make sense, you could actually catch that, raise an exception or whatever. If people are just setting the fields willy-nilly, circle.r equals -1, for example, that's not great because the radius shouldn't be -1. So it's stylistically preferable to do your changing of the data through methods, but you can actually just directly set them. Gaurav.
Isn't there any private variable concept in this thing like Java?
Yeah, right. So in other languages, you have. I don't know if Python has private variables. We should look it up. I haven't run into them. In general, Python lets you do way more stuff than you really want to be allowed to do. Yeah. Okay. So here's the circle, distance from the origin. Need to run this. And now I move the circle, and now it has a bigger distance from the origin because I moved it farther away. Okay, so other than init, there's some other special methods. For example, if I print my circle, I just get this not very helpful looking thing printed out. But if I try to print out a NumPy array, it prints out nicely. So why is it not saying NumPy object at 0x whatever when I print out the NumPy array? It's because the people who made NumPy defined this special repr method, which is down here. The one at the very bottom. So like init, it is a special method. And that double underscore kind of tells you it's one of those special methods. And what repr does is it returns a string, and that string so basically when you try to print out the object, it's actually going to call repr to get the string that will be printed out. And so here I say a circle at x, y with radius r. So if I do that, then when I print out the circle, it actually prints out nicely, and so that's great. And there's other special methods as well, but those are just the two we're going to talk about. Questions or comments? Yes, what's your name again?
Leslie.
Leslie.
So the methods that you have here, like circumference and dist and radius, all those things. So those, when you design them, I'm assuming that they're designed to only operate on the class. So in this case, it would be circles. Like, can they only take in circles?
Yeah, so the question is, looks like these methods are only for circles, and that's right. And we see that because they are all indented one level inside of this class circle. So that means those functions can only be used by making a circle and going name of circle dot name of method. Yes, name?
Monique,
Monique.
can you explain how the repr function is different than just like printing that
So,
statement?
yes. Up here, with my old definition of circle that didn't have the repr, when I printed it, it just did some default way that Python prints out objects.
But what if you made like a print function that said, I want to print this circle as something?
Yeah, so I could make a print function, but then I would have to go circle1 dot print, which is just not as beautiful as this. Because this actually says when Python tries to cast this object to a string for printing, it just automatically gets that. And so I could probably do, oops. Yeah, fine. Oh well. Anyways, yeah, it's just more convenient because it happens by default. Reiko?
Yeah, conventionally, should you always put a repr function, like whenever you make it?
Should you always make a repr function? I mean, that's a philosophical question. If you think you're going to print it out, sure, but I mean, if it's not worth your time, no, I don't know. Yeah, often, I guess, if you're going to be using the thing a bunch. Tom?
Is there any other important uses that we need to know for the repr function?
No, all the repr thing is really used for is when you try to print the thing, or I think turn it into a string, but mainly printing, yeah. There's a question back there?
That was the same question.
Same question. Okay. Yes.
Why do we not write the functions?
Is it big-nish? Okay, yeah.
Why are we not writing the functions directly under init?
Directly,
Under init?
why are we not writing them directly under? I think we are writing them under. What do you mean?
Under the definition underscore init. Like, why don't we just directly have self.area equal to?
Oh, I don't know. This is how it's done. Yeah, you have the init and then you have all the methods. Oh, I see. Well, I see. Okay, you definitely do not want this because, is that what you're saying? Yeah, you definitely do not want this because then when you make the circle, it computes the area, but then if you change the circle, the area is not going to change. So if area is a piece of data, if it's a float that you just store, then it's stuck. But if you make it a function, then whenever you call that function, it is on the fly going to execute this code with the current value of the radius.
We can't put area as a variable there. Pi r square we can't do there. Set dot area equal to,
You mean here?
yeah, as a function of pi we cannot give it.
Yeah, so this is not invalid Python code. It's just a bad idea because it's only using the current value of the radius when you made the circle.
It won't change with time?
It won't change in time because think about what happens. This is just going to happen first. It'll never happen again, right? Code just goes line by line, right? And then it's done, and why would it go back to that code? Because you never call init again. Init only gets called once. I forget. Zoe, right.
So what's the difference between repr and str?
What's the difference between repr and str? So repr says, if you're going to be printing this thing later, here's how I want it to look. So I actually said, make this nice English sentence so that the people can read it. So repr is the function that is going to get called every time someone tries to print out the circle. It's going to call repr and say, oh, this is how they wanted it to be printed out. And that's what it's going to show. Anas, yeah.
Going back to what he was saying, you can sort of like put self.area under the area function, under the area method, and then it would sort of like change the value, right?
Well, you could, but you don't really want to. Sure.
No, I mean, you assign it first, like up there, and then like if you ever want to change it, you can have it here, right? I think it sort of works.
Yeah, but that seems like bad design to me. I mean, there's no particular need to store the area here. Like the only need to store something is if you think someone's going to be calling the area function a million times without changing the radius, and it took a really long time to compute the area because it was a very complex calculation, then you may want to store or cache that value to not waste computation and recompute it every time. But here, for such a simple thing, there's no real need to store it, and just the extra hassle of it being stored, and then did it update, did it not update, it's just, it allows things to get out of sync because someone might update the radius directly by doing circle.r and you don't know about that possibly and everything. It's just, it's too much hassle for no benefit. And in most cases, you'll probably want to do it the way I've done it. Your name? Holly.
Yeah. Sorry, just following on the same question with the string question, because if you just try it now, if you go in and you physically change repr to str.
Oh, that's,
it still prints that.
Okay, I don't know. I don't know what the difference is there. So you mean this?
Yeah.
Yeah, okay. I don't know. Yeah. Okay, I'm going to have to cut you off here, folks, because we need to move on. So I'll have office hours right after class if you have more questions. Okay, next thing. I can't really run out of time today because it's my last class. So Python import. So we have been importing stuff, like import NumPy, without really talking about it. So now we're going to talk about it. So these things that we're importing are typically modules or packages. The details of those will come in a later course in collaborative software development. But a module or a package is basically just a collection of a bunch of classes and functions. That's what NumPy is. NumPy is just a collection of a bunch of classes and functions, like numpy.ndArray is a class, and all that kind of stuff. So we can import NumPy. Once we import NumPy, we can use it. We can use functions. So numpy.sqrt is a function that the NumPy package is providing. It is not a method of a particular class, because NumPy is actually the package. It just, you might want to take the square root of things kind of in general. Another thing you can do is you can import NumPy, but give it a different name, which is actually what we've been doing. It's conventional. Just because you use NumPy so much, just the shorter the name, the better. So it's just a bit more convenient, and more, by convention, to just call it NP. And then once I have NP in hand, I can, for example, call a function like this function that generates a Gaussian random number like you are doing in your lab. Another thing I can do is I can, if I don't want to type np.random.randn over and over again because that's too much of a hassle for me, I can use this from syntax. I can say from numpy.random import randn, and now the name of it is just randn in my environment, not numpy.random.randn, which is, it's just purely a matter of convenience. Now I don't need to type that long thing every time. I can just call randn. So that's kind of handy. You can also combine from and as, but I think this is just getting too confusing at this point. This is a bit much for me. But okay, from numpy.random import random as random Gaussian. Now it's called random Gaussian. That is valid Python as well. Okay. You can also just import everything in numpy.random. That's what the star does. The star just says, give me everything. So for example, binomial I don't have to say numpy.random.binomial. I can just call it binomial because I did this import star thing. So I used this syntax up here, but I imported everything, and I happen to know that everything includes binomial, so I can now draw from the binomial distribution. There's not really, this isn't super conceptual. It's just like, again, as I said one of the other times, just spamming a bunch of syntax at you, and you'll probably want to refer back to this later, but it needs to be said, so I'm saying it. Some annoying facts of life. Yes, so one thing that irritates me is that sometimes they will name a function the same thing as the package or module. So we saw this in an earlier part of this course, from random, import random. That's just so confusing because now it's like, is it random.random? Is it random? I'm not a huge fan personally, but there you go. It's also the case, so when we imported numpy, we could immediately use numpy.random. But if I import scipy, I cannot immediately use scipy.stats. That has to do with how the creators of numpy and scipy organize things, and there are good reasons for doing this, but you actually have to import scipy.stats like this to use scipy.stats. Again, that's based on decisions by the people who made these things. It's just a gotcha that you might get really upset if you import scipy and then you can't use scipy.stats, and just keep in mind you might need to explicitly import the kind of sub-module that you're looking for. The other frustrating thing in Python to me, so there's a package we'll be using later in the program called scikit-learn. To install it, you would do pip install scikit-learn, but to import it, you would do import sklearn. So I find that very annoying because I look at someone's code, I see the code says import sklearn, I'm like, oh, I need to install that to run their code, and then I'm like pip install sklearn, and it's like, never heard of that. So in R, those names match, which I think makes a lot more sense. In Python, they can be separate names. Dir. So dir, quick thing, dir. If you call dir of an object, it just tells you all the things you can do to that object. There's a bunch of underscore built-in things that you can just sort of skip over, but if you go to the bottom, you can see those functions we defined. So you could do circle1.area.circumference.dist, and also the data.r.x.y. So if you just have an object in your possession, you're like, what can I do with this thing? You can just dir it, and then you'll see all the things you can do by going circle1.x.translate. So that's just kind of a handy little thing to see what's available to you.
Super quick one on this. With the hash is in this list, but I noticed in the lab you had to like define hash, like bring it in. So are these available?
Yes.
Way, or?
Okay. These things already exist, but you can overwrite them. So repr init, there's a default one, and we are overwriting them with our own version. So that's what was happening in the lab with hash. We were putting our own version of it. Okay. So in the program, we usually work in Jupyter. Jupyter is really great for teaching and learning and all that kind of stuff. But if you want to have a big thing of code, you're going to actually have to get out of Jupyter and put them in Python scripts, which you're going to talk about in a later course. However, I just want to talk about what is going on here very briefly. So I restart the kernel. And now there's no such thing as circle because I just restarted the kernel. I have not run the code that defines circle. But I have a file called circle.py that is in the same directory as my Jupyter notebook. It's just a different file on my laptop. And here I put all the stuff in there that we talked about. And I also put in just a variable, an integer, and a function that doesn't do anything just for illustrative purposes. So in this circle.py, I have a class, an integer, and a function. And then what I can do back here is I can say from circle, import circle. So all that import syntax that we just talked about for numpy, scipy, you can use that for your own code that you wrote and just stuck in another file. So here I said from circle, this circle with a lowercase c has to match the name of my file, circle.py, and then circle with the uppercase c, that has to match the name of the thing that I'm importing from inside that file. And so I can import it, and now I can actually run the code. So that's kind of more practically how things are going in bigger projects, is you're putting stuff in files and importing them in various places. And I could actually, well, I don't have the function yet, but if I import everything from circle.py, I now have the function and the integer. So that is to say, you can import classes, functions, variable data, all kinds of things. And in fact, with NumPy, that's what we were doing. So I'll show that in a second. So the type of circle is a type. The type of the function is a function. The type is a constant is an integer. And we imported all of those things. OK. And C is the circle object that we made. So we have a type, function, an integer, and a circle. Yes. Your name?
Annie.
Annie.
If you know that you're always going to use like 5 different packages, can you put it into another file and then import that file, kind of like you did?
You could, but yeah, the question is, can you put all your imports into another file and then import that file? Typically, you should just put all your imports at the top of every file, the ones that you need.
You could?
I'm not sure that you could, actually. You'll have to try it. Yeah. Kind of feel like you can't in Python. OK, so in fact, when we imported NumPy, we were also importing all these different things. Like we were importing numpy.ndArray, which was a class, but we were also importing so numpy.py, for example, that I used earlier, that's just a float, just like this integer. So when I got the NumPy package, I actually brought in a bunch of classes, a bunch of functions like numpy.square root, and a bunch of just variables. So because of the time constraints, we're going to have to skip the break. I'm very sorry. I hate to do this, but today's my last lecture, so apologize about that. I just have to get to the end. Intriguing behavior in Python. OK, so look at this code. X equals 1, y equals x. And now I'm setting x equals 2, and I'm printing y. So what do you think is going to happen? Is y going to be 1, or is y going to be changed to 2?
1.
I heard both things. The answer is that y stayed the same as 1. So when I ran this line of code, y equals x, I took the current value of x, which was 1, stored that in y, and then when I changed x, y was unchanged. So here's another one. I have x is a list containing one element, so it's exactly the same as the above example, except I'm just wrapping that integer inside a list with one element. So x is now the list with one thing in it. Y equals x, same thing. There's only one element, element 0. I'm setting that element to 2. And what do you think is going to happen? Ooh. OK. That is correct. So that is very weird. I mean, you would think it would at least be consistent one way or the other. So this is something we need to talk about, because something as simple as this, we should really be able to predict what's going to happen when we run code like that. So I want to try to introduce some method to the madness, as it were. So let's launch right into it. In Python, when we have the list x, it is something called a reference to a place in your computer's memory. So somewhere in there, in my laptop, there's some memory chip, and in there is the data. You could think of it as a physical location. It pretty much is a physical location, just a very tiny one. So the word location you could even think of literally if you wanted to. And the variable x, when x is a list, it's basically saying, where can I go to find that stuff in the list? That's what a reference means. Now, when I set y equal to x, I'm saying, well, so I don't know, here is my list with the number 1 in it, and here's x, and the variable x knows where to go and find the stuff inside that list. And when I say y equal to x, well, what is x at this moment, actually? X is the ability to go and find this stuff. So when I set y equal to x, then that's what's happening. Y is now just being told where to go find that stuff, because that's what x is, pretty much. X is just a reference, a location, an address, if you will. So after I set y equals x, this is kind of the picture that you should have in your mind. And then when I take x0 and I set it to 2, I say, oh, here's x. x0, that's the first element. I'm going to set it to 2. Then it changes. So by the way, if I had done y0 equals 2, it would have also changed x. It's either way. Changing x would change y, and changing y would change x, because they're really both just addresses to the same place. However, so in a way, actually, it's this first thing that is weird. Because the second one that we talked about could potentially make sense. So there are some special cases, some of these basic built-in types like integer, float, Boolean, where when x is an integer, x is literally just 2. It's not, here's where you go and find the 2, but it's literally just the 2. And when I say y equals x, it's just saying, well, what is x? X is literally 2. And so y just becomes 2 as well. And that's why when x is an integer, then changing one of them causes the other one to not change. So in this scenario, changing either one causes the other one to change. In this scenario, changing either one doesn't cause the other one to change. And my analogy for this is, in the list case, it's like I share my Dropbox folder with you or my Git repo, and then you go and mess with it. You have now messed with my stuff, because I gave you the link or the URL to where the stuff is. But if I emailed you that stuff as an attachment, and then you went and changed it, that's this scenario. I didn't give you the location of the stuff. I actually sent you the stuff itself in an email attachment. So you have your own version, and whatever you do and whatever I do, they have nothing to do with each other. Questions or comments? Karan?
So if we have same variable in 2 different methods, will it create 2 different memory allocations in heap space, or it will be a same heap space?
Okay, we'll talk in a couple minutes about how this happens with functions. So just hold off on that. Right now, we're not even dealing with functions yet. Yeah. Any other questions? Oh, sorry, James.
So just to clarify, when you create a variable named y, does y point to x or the?
You mean over here?
Yeah.
Yeah, I would say the way to think about it is not that y points to x, but rather that y and x point to the same place. So in fact, in this case, when you do y equals x, at this point there is no difference between x and y. It's not that y points to x, but x doesn't point to y or something like that. It's just they're exactly the same thing. Yeah. Any other questions? Okay, so here's another one. Oh, I think that's just exactly what I just said. Oh no, it's not exactly what I just said. Okay, here's another one. I make x the list 1. I set y equals x. But now what I had before we had x0 equals 2. That was the code we had there before. So it said take the first element of x and change it to 2. But now this time, I'm actually setting x equals list2, which is what we were going to end up with anyways, by the way. Right? We had the list 1, and then we were taking that element and changing it to 2. But what happens here is that it doesn't change. So you can see this is a bit of a rabbit hole of weird stuff, because you probably just thought, oh, okay, lists, they change, ints, they don't change, done. But it's a little more to it than that. So let's talk about these 2 lines of code then. 1 was this, and 2, those are the 2 versions that we did that actually had different behaviors. So in this top thing, what happened is that x of 0 says, go to the place where that stuff is, and find the 0th element, which is this, the only element, and set it to 2. That's what that first line of code does. This says something else. First of all, the right-hand side kind of happens first in Python. So this happens, and what does square bracket 2 square bracket does? It makes a new list with just 2 in it. So this happens first. It makes a new list with just 2 in it. And now it says x should point to that new list. So we were in this scenario, but then we did that. We said we made a new list, and then we told x to point to, and that actually goes back to James's question. That's perfect, right? Because you can see y is not pointing to x. Y is not following x along for the ride here. Y is just pointing to that stuff. And so here, y is still 1 because y was pointing to this original stuff that x was originally pointing to. Questions about this? Name?
Rory.
Rory.
What happened to the list that has no pointing to it? So
What happened to the list that has no variable pointing to it? Right. So in Python, the language will kind of take care of that for you. It's called garbage collection. It's just going to figure out, well, they can't possibly use this anymore because nothing is pointing to it, and it'll just be freed up from memory. In other languages like C, you have to deal with that yourself, but we don't have to deal with that. Yeah, by the way, since we didn't take a break, if you need a rest or a bathroom break or anything, feel free to go. I don't mind. Any other questions? Okay. So additional weirdness. Okay, additional weirdness. I'm making a NumPy array. 1, 2, 3, 4, 5. I'm doing y equals x again. And now, in one case, I'm doing x equals x plus 5, and the other case, I'm doing x plus equals 5. As far as most of us are concerned in day-to-day life, those are equivalent things. X equals x plus 5 and x plus equals 5. At least I was taught like those are pretty much the same thing. Plus equals is just shorter and therefore more convenient, end of conversation. No, actually, they differ in that the former case doesn't change y, and the latter case does change y, and it's similar reasoning to stuff we just talked about. Let's talk through it. What happens over here is, again, the right-hand side evaluates first. So x plus 5 happens first. In NumPy, when you take a vector, add it to a number, you get a new array, the same size as the original one, but 5 added to every element. So a new array gets created there that holds 6, 7, 8, 9, 10, and then only x is pointing to that, just like we had over here. It's very much analogous. Whereas in the second case, plus equals, there was no way to know this really in advance, but the designers of the language or NumPy or whatever decided that plus equals meant go in there and change the stuff. And so therefore, x was still pointing where it was pointing, but that stuff got changed, and therefore y is also affected. So it's very analogous to the discussion we just had, but also kind of shocking at the same time that plus equals behaves differently than the thing you might think it was the same as. Questions?
So, I mean, all of this explains that we need to keep printing the variables that we are working on.
All of this explains that, first of all, if you never even knew about any of this, it might be very hard to debug if this wasn't even your space of possible things that could ruin your day. At least now you're aware of it, you can look for these kinds of bugs. Even better, you can look at the code and predict exactly what would happen and say, oh, that's a bug, or oh, I'm going to write my code this way. So it is very much better to be aware of this, to have this on your radar, even if you don't remember every single detail of what I just said, versus not having it on your radar. Okay. Function calls and references. So now we get into functions, which is what I think someone, Karan, maybe was asking about earlier. So what happens when we start mixing all of the mess that we just talked about with the idea of calling functions? It's actually very important to talk about this, even though you might be getting a headache. So here's a function foo. It takes in a variable y. It then overwrites that variable y with the string hello from inside of foo, and then it returns y. And now x is on the outside looking in, and I call foo of x. So that means x is kind of getting sent into the function, if you will. And the question is x going to get overwritten with hello from inside foo, or is x going to be I'm outside when I print it? What do you think?
Outside.
Again, I heard both, which is great. At least half of you are going to learn something. Okay, so here's what happens. And why did this happen? So, well, first let me show you the other case. So the other case is that x and y are lists. So analogously, I'm just taking the thing and wrapping it in a list. And now I'm setting y of 0 to hello from inside foo. And now I'm just printing out x. And here, it actually got changed. So how to process this? First of all, the strings is kind of just a distraction. Those strings could just be the integers 1 and 2 like we had earlier. It makes no difference. There's no significance to the fact that I'm using strings here instead of integers. So what's happening is basically this. I have a variable x called I'm outside. Now I'm calling foo of x. So in other words, I'm calling foo and I'm passing in the string I'm outside. And so right here, y is taking on the value I'm outside. But then what's happening here is you're overwriting the value, just like if you had, think about if you had like this, y equals I'm outside, and then you had another line of code right after that says I'm inside. You know what would happen here. Y would be I'm out, and then it would get overwritten with I'm in. And you can pretty much think of the function as, just forget about the whole function, just think about it as you're jumping to another place in the code. That you can kind of unroll the function in your head. You can say this happens first, then this happens, which jumps me up here, and in the process I'm kind of setting y equals x, basically. I'm setting y to the value that was passed in, which was x. And then I'm overwriting y with the string, and it's just like the integer above, exact same thing. They're both just pieces of data. I'm overwriting it, and then x is unchanged. But here, with the list situation, now what I'm passing into the function bar is the list. So here inside the function, y is actually the list containing the string I'm outside, and then we're going and modifying that list, just like we talked about earlier. We're saying y of 0 equals, and so if we draw this out, we start with x pointing to I'm outside, and then when you get inside of the function, now y is going to take on the same value of x, because when you start the function on that first line, def bar of y, it basically means we're going to have a variable in this function called y, and it's going to be determined by whatever you passed in, which was x. So it's really like y equals x. And then you're changing one of them, and so you're changing the other one. So all those same rules apply. It's just much harder to read what's going on when you're jumping around the code in your brain and going inside and outside of functions. Questions about this? Karan.
So suppose there are two methods. Both of these methods, they have a variable called y, and they are returning y. This y variable is a shared variable in heap space.
Yeah, so the question is if you have two functions. Okay, we're still going to get to that. Keep hanging on there. Yeah. That's coming. Tiny.
Are there other types other than lists that act like this?
Yes. Are there other types other than lists that act like this? So basically, list is the normal case, is kind of the point I'm trying to get across. And integer, string, whatever, those are the weird case. So list, tuple, dictionary, your own circle class that you define, NumPy array, all of those things are just passing around the reference. And then there's just a couple of weird ones like integers that are not doing that. Kenneth?
Yeah. Does the creation of new lists apply to like stuff like list.pop or list.append?
Right. So yeah, list.append. List.append does change the list. So just like this syntax up here changes the list, list.append also changes the list. List.pop also changes the list. So all of those things are going to affect any variable pointing to that list. List.append does not make a new list that is a copy with something appended to it. It actually changes it. Okay. So again, you have to be just very careful about this, because here, in this case over here, we printed x, and x was unchanged because it wasn't stuck inside of a list, this foo function. Here, again, you have the same thing with the foo function. And here x does change, and then you're like, well, what just happened? Again, this is violating all the stuff Mike says, and it's because here, this is the new part, the stuff I highlighted. So what happened in this case is the foo function actually returned the string. Like, we haven't done anything with returning so far. We were just talking about passing things in and messing with them. But if the foo function returns the string, and then I set x equal to that, then sure, I'm going to overwrite x with hello from inside. But it's tricky because it just looks so similar to this code up here. It's just I put in the x equals, and now again, the situation has changed. So it takes a lot of patience to stare at one of these things and really step through in your head what Python is going to do. And I wouldn't say you have to be perfect at it, but it's a good thing to start doing because it's quite a useful skill to be able to predict what your code is going to do. Of course, you can always run it, but it's even better to know what it's going to do. Correct.
And is this the right thing to say that assignment operations, they are immutable until and unless they are reassigned?
Say that again?
Assignment operations, they are immutable until and unless they are reassigned?
I don't know. I'm going to skip that one. Any other questions? Okay, let's keep going then. Yeah, here's some terms you can look up if you're interested in this. So just to summarize what we've talked about, you don't need to memorize special rules for calling functions. Functions actually behave the same as not functions. If you think of outside the function, the variable is called x, inside it's called y, you could just think of that as y equals x, and everything else is the same. So yeah, int, float, bool, I guess string are some of these weird ones. And now you can see why we care if objects are mutable or immutable. When you pass a mutable object into a function, you are letting the function mess with your mutable object, which is not great. So I shouldn't have said tuples before when I was answering Tiny's question, because tuples just can't be changed. So none of this applies. Yeah. So the general rule, and maybe this is what you're getting at, Karan, the general rule is when you do assignment, x equals something, then you're not modifying the original. But if you do x dot something equals y, or x square bracket, or x times equals, those types of things are going in and changing the underlying data in your list or your NumPy array or whatever, or your circle in the case of x dot something. So if you had a circle C and then you had D equals C, and those are pointing to the same circle. And if you did C dot R equals 5, you've now changed the other circle as well because they were pointing to the same circle, just like lists. Okay, I'm going to talk about copy, which is a Python module that you can import. So here's just a reiteration of what we saw earlier. This is not new. X is the list 1, y equals x. They both point to the same list. Now I changed that list. I've changed it for both x and y. So you've seen these 4 lines of code before, but now instead of y equals x, I'm going to do y equals copy.copy of x. And what that does is it actually allows them to be separate. So copy.copy says, no, y is not just pointing to the same area as x. It's actually making something different. And so then when I change one, I'm not going to change it. And that's pretty useful, you can imagine. Because if this is undesirable behavior, you might want to use copy-like functions to say, no, I just want a new one so that I'm not messing with the original. For example, inside of a function, you might choose to just immediately copy something that's being passed in so that you can mess with it inside the function and not mess with it for the person calling the function. So here's a good one. So I'm making X a list of lists. This list has 3 lists in it, as you can see. I'm doing the copy thing, following protocol. I'm changing the first element of the first list. That's this 1 right here. I'm changing that 1 to the string Pikachu. And then I'm printing out X and Y. So now, I guess this lecture is just like repeatedly building hopes and then shattering them. So you would think copy.copy is supposed to protect you from all that, but it didn't. So here, actually, both of them got changed, which was exactly what we didn't want to happen when we did copy.copy. And so what's going on here? Why was it OK with the list, but not OK with the list of lists? Well, here's this picture that I drew on my whiteboard and took a picture of. So here's X. X is a list that has 3 elements in it, elements 0, 1, and 2. That's why I put the 0, 1, and 2 there. And the 0th element of that list was another list with a 1 in it. The first element was another list with 2 and 99, and the second one, 3 and high. And when I called y equals copy.copy x, it did make y into a different list from x. That's true. They were now different lists, but they were pointing to the same sublists. So x was now a list of 3 references, a reference to the list containing 1, a reference to the list containing 299, and y is a different list, but happens to be containing references to the same places, which is a huge disappointment. So here's these references, if you will, are not the same, but they're pointing to the same data, and so when I changed that 1 to Pikachu, they both got messed up. So how are we going to deal with this? First of all, there's a new operator you might want to know about called is, which is going to help us just probe what the heck is going on here. So x equals y is true. I mean, we printed them out. They look the same, right? But x is y is returning false. So this is like equal, but it's saying are x and y literally actually the same thing? And here they're not, because we did copy.copy. They're actually 2 different lists, one over here and one over here, all telling you to go to the same place to find the other stuff. whereas equals equals is more of a weaker condition that just says, I mean, are they pretty much the same? And are they really exactly the same? That's kind of what's going on here. So that can be useful for you to just assess the situation and see what's going on. So here's what I think is the best way to illustrate this. Y dot append 5. Now you can really see that x and y are not the same list. Because I did copy.copy, these got decoupled. If I hadn't done copy.copy, they would have both had the 5 appended to them. But the copy.copy made them different lists. And now, both of them point to the list containing Pikachu, the list containing 299, the list containing 3 high. But y has another element in it, which is 5, which proves that they were not the same list. They were just 2 different lists pointing to the same 3 sublists. Questions? Brian?
Yeah, the first one, the equal, like when you made a copy, I would think that they're pointing to 2 different locations, so they should be equal. What is equal?
Yeah, I don't know what equal does exactly, but I think it kind of checks that they have the same stuff in them, which they do.
Like a shallow comparison?
Well, I think it's more the other way. I think equal looked all the way inside, I think, and said there's the same stuff in there, but I'm not actually sure about that. It's just, if 2 things are equal, then doing stuff with them, it's not going to matter which one you use. But still, changing one may not change the other, as we just saw with this append thing. But if 2 things are each other, they are the same thing in every conceivable way of being the same.
Now that you added 5 to
yeah, now they won't be equal anymore. Yeah. Yeah. Okay, I think there was another question. Nikki?
How can we copy inside of this?
How can we copy? Yes, well, that's the next thing. The next thing is, how can we solve this nuisance? And the answer is deep copy. So deep copy just says go all the way down inside of these data structures and just copy everything so they're completely different and not entangled in any way. And that is exactly, no, that's fine, that's fine. Okay, we can salvage this situation here. We just need this to be redefined. It's just x already had the, there we go, okay. Great. So when y makes a deep copy of x, it's actually saying here's a different 1, a different 2, a different 99, or a different list containing 1, I should really say, a different list containing 2 and 99, a different list containing 3 and high. So they're just parallel universes. Everything got copied out. And so now when I change this one, they weren't reusing the sublists anymore. They had different sublists as well. So that, you may need to copy stuff, and you may have bugs in your code that are because you didn't copy stuff, but then sometimes you need to deep copy stuff. If you don't care that much, you can just always deep copy. The reason not to do that is it could be very slow if you copy more things, and it could also use up a lot of memory. If you have some giant thing and then you deep copy it, now you have 2 giant things, and that takes up too much memory. That might be undesirable. So the language gives you the control to copy kind of as deep or shallow as needed to solve your problems without wasting time and memory. Okay, we have to keep going here. Scoping is the next and last thing. So, and this I think is what Karan was asking about earlier. So here's the thing, I have a function f. It has a variable x that it sets to 10, and outside the function I set x equals 5. I call the function, and x doesn't get changed, and that's all good. I wouldn't really want x to get changed in this circumstance. And here's another case. I have a new variable that is being set to 10 inside of the function. I call f, and then I check, does new variable exist outside the function? New variable was only ever created and defined inside the function. Is it still there hanging around outside the function? And the answer is no. And that's good. I'm pleased that they went at least this far in Python, because I don't want that outside. If I made it inside the function, I just want to leave it inside the function. And so this whole notion, this whole discussion is called scoping, or the scope of variables. Where do they exist? Do they exist over here? Do they exist over there? And this behavior up here is all nice and good, and you'll see similar behavior in other languages, but you'll see weird stuff in Python that is not allowed in other languages that I need to show you in the remaining 5 minutes. So here is one of them. So I have S. I'm defining it out here as hello world, and then I'm calling bat, and I'm saying, can bat get access to that hello world that was defined outside of it? And it can, which I'm not personally a fan of, and I really don't want you to write functions like this. If you need it, just pass it in as an argument, so someone can see all the things coming in, so here's another one. This time I'm taking in an argument, S, and then I'm printing it. And here what happens is, well, the question is, what is S going to be when I print it? Is S going to be the S from outside, or is it going to be the S that I passed in? And it is the S that I passed in, which is reassuring. At least if I pass in another string, that's what it's going to be. At least that is a relief. Otherwise, things would be really horribly broken. So here's where it can go wrong. Here's a function called modify the stuff. It takes in no arguments. It looks very harmless, but it modifies the stuff. And you just look at the doc string of this function. It talks about all the arguments. There's no mention of the stuff, because the stuff is not an argument to the function, is not returned by the function. You are innocently hanging around with the stuff, and the function actually modifies it. I really do not like this behavior of the language. It just feels so dangerous that a function can modify this variable that's not really its business to be going and modifying. And then after you call the function, some random variable that the function supposedly has nothing to do with got modified. What can I say? Don't do this. It's just not good, right? I mean, best case scenario is the function just returns a value and you use that. But if not, at least say, make it an argument and say in the doc string, this function changes this argument that you passed in. At least that would be a bit better. So yeah, as I said, safest, functions don't mess with things. Acceptable, functions mess with things, but at least you documented it. Disaster is a function with undocumented side effects on its arguments, at least. And complete disaster is what I just showed you, that, well, first of all, this is going to throw an error if the stuff is not defined, and it might not be. It happened to be in this case. But then when it isn't throwing an error, it's just changing some variable outside the scope of the function, which is not nice. Another thing to not do is don't name your function variables things that are default things in Python, like length or lambda or whatever, because you're just going to overwrite length with this. And now when I try to call the length of this string, I can't, because len has been overwritten by 5, and it's just going to throw an error. So don't name your variables anywhere, in functions, not in functions, things that already mean something else. And what am I saying here? Yeah, these were supposed to be. So here's another thing. I have a variable outside the function called a, and I have a variable inside the function called a. And I think this also may have been what Karan was asking earlier. So, I mean, this might happen. I can't say never do this. It might happen, and it's not the most horrible thing ever. But they're different a's, right? In this case, there's the a outside the function, and there's the a inside the function. And I can do stuff to the a in here, but this is a different a over there. So basically, the function is going to, if you use a, the function is going to say, do I have something called a? And if not, oh, let me just see if there was something outside the function, which is a bit weird. Last thing I want to say is just functions can see each other. So I think you already saw this in lab 1, but like if I have a function called f, you can call f from g. There's no reason not to do that. You do not have to pass f as an argument to g to call it. You can just call it, which you have already been doing in lab.